welcome to the House of zk Radio, which is a focused podcast and media channel exploring everything zk, zero knowledge. All right, hi everyone. My name is Alice. I am host of House of zk Radio. I'm joined here today with Diego, who's co-founder of Aligned Layer. Super excited to have you here today, David. Diego.
Hi, Alice. Thanks a lot for having me. It's a huge pleasure to be able to talk with you about Aligned and other CK stuff here.
Yeah, really excited to have you. I'm wondering, Diego, if we can first start off with an introduction to yourself. So, what got you into the Web3 and zk spaces originally? And then also, I'm curious to hear about the intention behind creating a verification layer. And maybe you can also speak about the importance of verification, especially in today's digital age.
Well, we can start maybe with verification if you want, and then I'll give you like a little bit of my background. So the thing is, blockchains are really verifiable computers, okay? And they achieve this property via re-execution and consensus. So there is an easy way in which you can always verify computation, which is you just re-execute. The only problem is this is not efficient because every node has to perform exactly the same work. And so if you try to add more computers to the blockchain, you are not going to make it faster. You make it more robust, okay? But we'd like to have this nice scalability property from Web2 where you add more machines and you get like more computational power. And we had these developments from the late 80s and beginnings of the 90s, which showed that it is possible for computations to be verified in a more efficient way. How? By generating these cryptographic proofs. Okay, and so it took like some time until we had like viable constructions to do this efficiently, and we could find like a use case. Because in the 90s, maybe you are not going to delegate an expensive computation. It didn't make like any sense. But with blockchains, you had like the right use case that could then finance all the development of these new technologies, proof systems, engineering, and all that. So that's what verification of CK is all about. But the problem is this is expensive to do on chain. Why? Because first, the blockchains that we commonly use were not designed with this technology in mind. And then Ethereum has like some limitations given by the EVM. And so we thought, okay, maybe there's a way of getting around and reducing costs, because this is one of the real bottlenecks that we have for the adoption of this very disruptive technology. Okay, so that's more or less on verification. I don't know if you want me to clarify anything, please.
Yeah, absolutely. And I mean, it's really exciting time that we're now able to kind of redefine our traditional models of trust or of re-execution. And now we can just provide these cryptographic proofs. But at the same time, as you mentioned, on the verification side, there's still bottlenecks when it comes to cost. So I wanted to also dive into kind of your thoughts about the general zk landscape. So you mentioned that blockchains are kind of the first big use case for zk verification. I'm wondering if you have any predictions for other types of use cases, maybe sometime in the near future, or even those beyond Web3.
Well, something that I am really excited about is zkTLS, because that will allow us to bridge the world to web into the world to web, Web3 world. I think that this unlocks lots of interesting applications and also like allows us to onboard more traditional services and companies. Um, because really, I think that blockchain will be permeating everything as much as AI is going to do so. And the good thing about blockchain is that you get like credibly neutral infrastructure. Okay, so this would be something really nice that we could get. I think that also there are like some interesting applications when we also consider um, privacy into the equation, and so we can choose to selectively disclose some information or not. Right now, a lot of our information is freely available on the web, and we have no way of choosing uh, what we want to disclose and what not. So I don't know, if I googled me, I would find like lots of details that maybe I don't know. I don't want everybody to know about it.
Yeah, so definitely a lot of applications, even within the privacy sphere, getting to choose what kind of information is disclosed and what is kept confidential. Yeah, I believe also that that's going to have many, many applications within the future. But going back to verification costs, you mentioned that the cost for proof verification on chain is very expensive. I'm wondering if you can make a comparison and kind of also um, go into the need for a verification layer compared to, say, direct verification on the main layer one, like directly on Ethereum. So I'm wondering, how does verification on a line layer compare to directly verifying back on the L1?
Okay, so the thing is, we have to understand that Ethereum is a decentralized computer, but it has a very limited computing power. Okay, with gas limits that we have right now, Ethereum is able to verify at most 10 proofs per second, okay, or 120 per block. Um, so this doesn't scale really well if you want to build or make Ethereum like the trust layer of the world. Okay, if you want to have like lots of banks, payment systems, auctions, whatever, it falls like really short. Okay, and this has to do because there is this limitation. The EVM cannot be like parallelized, and besides, the cost depends on the existence of some precompiles, and this is kind of a bit arbitrary. Why is this proof system much cheaper than this one? From a technical point of view, maybe it doesn't make that much sense. Okay, in fact, when we were like thinking about Aligned, we really were trying to solve another problem, which was zk bridging, and it's essential to solve interoperability. But the problem is, who's going to use these bridges? Is if every time we want to do something, we have to pay maybe $6, $10, $20. We want these to be like really, really cheap, so that the marginal cost of using this technology is negligible. And so we were thinking, is there a way in which we could get like programmability or verifiability on top of the EVM without all the downsides of the EVM? And that's where we found precisely EigenLayer. In fact, we've known Eigen for longer, but it was at that moment that we saw how all the pieces went together. Um, and so we said, okay, we can create a decentralized network of verifiers. They can take this job, they can run verification outside the VM with no limitations, and we know verification is very efficient. We can also parallelize, optimize verification for speed and not gas costs. And yeah, this begins to unlock like several alternatives. Besides, what we could do is very easily like batch together proofs from different proof systems without any need of doing like any expensive like proof recursion or some compression technique or whatever. And that way we could like really scale down the costs. Of course, there is a very simple approach you could use, which is you just build your own L1 from scratch and you design it to be like verification friendly. But the problem is, then you are out of it, Ethereum. You have to also bootstrap the security of your network.
Mhm.
And you have the problem of your token, and the security depends on the token. And say that you get a problem, the token price goes down, then your security goes down, which in turn sends your token even down, and so you enter in this what they call the death spiral. So we said like, okay, we have eigenlayer, we can provide the security of the network we are staking. We are still connected to Ethereum, which we believe is the place where people want to build. It's kind of the New York of blockchain. Um, and so we said, okay, now we have all the pieces. We have a way of securing the network, stay connected to Ethereum, and at the same time verify proofs much cheaply and faster.
Mhm. Yeah, and it's really great that you guys chose to inherit specific characteristics in staying connected with Ethereum, like say with security guarantees, and at the same time also be able to make your own optimizations within your verification layer. So really great to hear kind of the approach that you took in making those design considerations. Also, going into some more detailed about Aligned itself. From my knowledge, you provide multiple modes. So there's the fast, and then there's also the aggregation mode. So in what scenarios would a user choose one mode or over the other? And I'm wondering, in providing these different kinds of modes, how do you see the developer experience being affected?
Yeah, no, what we wanted to give was developers back the choice to choose which proof system suits best their needs, and also to choose the the amount of security they want, because there is a trade-off in general between um, latency and security and cost. Okay, if you want to get very low costs, you have to like wrap your proofs with several others. Okay, and that takes like some time, so you add latency. So we wanted to give people like the option based on their application. So in the case of the proof verification layer or fast mode, the idea is you send proofs, and these get verified by each of the each and every one of the operators. They just sign a message saying these proofs are okay. We aggregate the signatures, see that there is a quorum, and then we update the state in Ethereum. Okay, and the security here is the one you get from restaking. Okay, right now, last time I checked, we were around uh, 3 million ETH. So before, well, prices going down, it was like uh, 8 billion, which is more than enough for lots of applications. That is to say, if you are like, I don't know, trying to create an online leaderboard and you want people to submit a proof of their score, you don't care too much about like having the full cryptoeconomic security of Ethereum. The same would happen if you want to do like some bridging or some transaction where the amount of money that is involved is like not significant. Um, but if you are like a rollup and maybe you want to get or inherit the full security of Ethereum, then okay, maybe you are willing to wait for a bit longer and perform this proof aggregation service or proof aggregation with the proof aggregation service. Um, and yeah, then you get the full security. Okay, but if your application, for example, is very sensitive to latency, then the fast mode is clearly the best way to go. Um, and besides, the idea with the fast mode is that you can use like practically any proof system. The only thing we have to do is just add the verification code for your proof system. Right now, I think we have Glot 16, several versions of Starks from different VMs. We've been talking, for example, about including Noir with one of its backends, and that is very easy to do. We wanted to make it so to give like developers, okay, which is the proof system that you want, and be able to choose it and still get like the benefits of chip verification. And in Aligned, it doesn't matter where you are, whether you are a Grot 16 proof, a Stark proof. The cost is going to depend only on the amount of proofs that are batched together but not on the particular identity of the proof system.
Got it. And it's really great to hear how much flexibility you provide to users. So within those different modes, if users say prioritize speed or have like some kind of latency issues, then the fast mode may be more appropriate. Whereas if they want to inherit or get the full security, then perhaps the aggregation mode. Then it's also really great to hear that you also provide compatibility with a variety of different kinds of proof systems, depending on the user's needs and depending on what they currently have. So it's really great to see all the variety of choices and flexibility that they're offered. And I'm also wondering, I know Aligned is also thinking about TEEs as well. So I'm wondering, what role do TEEs have in verifying these remote attestations on Aligned? And do you see any kind of scenarios in which TEEs can be used as an alternative to ZK in certain applications? If it's, say, has some benefits in saving some costs, or if it's can provide an additional way of providing integrity or any other sort of advantages in certain applications.
Yeah, in the case of TEs, really what you are doing is trusting the manufacturer that everything is all right. The advantage is with TEs, you can get a guarantee of integrity much faster than you would get with CK. So for some applications, it is even like infeasible to get this integrity proof. Um, so this can be a way of at least getting like some integrity for some computations that right now we cannot do directly with ZK. Also, I think it offers another advantage that you can use it as a second safety net because you're relying on your proof system to provide integrity. But we know that there are bugs, and some of them are really subtle and difficult to find. So having like T's, for example, as a redundant mechanism. So you say, okay, in order for this state to be updated, I need the CK proof to be valid, but also the attestation of the TE to be valid. Okay, this offers you extra security, and in order to like cheat you, they would have to break simultaneously the TE and your proof system. Okay, this is something I think Tyco originally was using. They started with attestations with TEs and then adding a proof system to generate the proofs. Of course, the problem that people using TEs face is that verifying these attestations on chain is also like pretty expensive. So that limits again the kind of things you can do. But the good thing is with Align's proof verification layer or fast mode, you could verify the attestation directly and get like the benefit of cost reduction, because really in the end Aligned is all about operators verifying some computation and then signing a message saying this is correct. Okay, so you could use Aligned to verify these attestations in a similar way to how you verify proofs. In fact, we've been even more flexible with Aligned, and we've used it in one concrete application, which is the Mina bridge. They are still auditing it, but the idea was in the Mina bridge, you have to check not only the correctness of the proof, but you also have to perform all the consensus checks. And these consensus checks in Ethereum are like super expensive. So what we talked with the Mina team was, okay, maybe we can create a specialized verifier that checks the proof and at the same time performs all the consensus checks. And it is valid only if both checks pass. And so that way you simplified a lot the smart contract and all the logic, and you just get Aligned to verify the consensus and the proof. So it's really flexible what you can do, and we've been thinking of different ways of taking advantage of our proof verification layer for some applications.
Got it. I see. And I also wanted to ask you more about some of the motivations behind the incentive mechanism that's used for the operators within the network. So curious to hear more about the approach you guys took in making that incentive mechanism design.
Yeah, the idea is that the network will be secured by dual staking mechanism. We still haven't designed that part for the Align token. Um, but well, the idea is that operators receive some kind of reward by running the ABS. Some of the things are really not like fully implemented or fully discussed. But the idea is that well, Aligned will offer like some pricing modes. We were thinking about having maybe a way by which you stake like some tokens, and then you send all the verifications that you want, and then at the end of some period, some of those tokens get redistributed to the operators. But that is mostly like RJ's area. He's more on the business side and talking to operators and everything. I mostly focus on cryptography, but well, we wanted to have also the Align token um, to help like secure the network and at the same time help like pay for the fees, because in Aligned you have to pay for right now the creation of the batch or the task, and then you have to pay for the verification of the aggregated BLS signature. And then in a later stage, whenever you want to query the contract to show that the proof is valid, okay, then you have to pay that. But that is like normal in many places. So we have to develop a mechanism to pay for the three tasks and ensure that you pay as little as possible. And we already know like some ways in which we can further reduce all those costs, but really we are super thankful to all our operators. I think we have like over 40, nearly 50, and yeah, they've been like super professional, and we are really thankful to all of them.
Got it. And I'm also curious on the user experience side. I'm wondering if you can give us a walkthrough on what it looks like for a proof to be submitted and then verified on Aligned, and how that may compare to the user experience, say, like if someone were to do it directly on the L1.
Yeah, in the case of DL1, you would just have to send your transaction asking for the verification. But the problem there is that you would have to first like code the verification code in Solidity. Okay, once you have it, it's a one-time job. Okay, and it's there. But in the case of Aligned right now, the user, what he would do is just interact with the batcher using, for example, our SDK or CLI. They would send the proof to the batcher. The batcher would then wait until it gets sufficient proofs and create a commitment to that data structure using a Merkle tree and post the root to Ethereum, creating effectively a new task. Okay, then all the data is stored in a place where the operators can download everything, run all the proofs. There they can use parallelization, for example. It's really fast. You can get like very, very high throughput. You can easily in testnet we tried that we got like 4,000 proofs per second, and I think we could have gone even higher. And once they all say, okay, this is okay, you get at least two-thirds saying this is okay, you get the aggregated signature and you update the state of the batch to verify. Okay, and then the batcher is going to return to the user the necessary information to show that his proof is a valid proof included in that batch, which consists basically of a Merkle authentication path. Okay, then the user just simply queries Align's contract using that um, Merkle verification path, and everything shows that it is included, and so he gets the result that the proof is valid, and then he can do whatever he wants. Okay, so it's really easy. We try to make things um, as clean as possible, and in fact, if you want to try, you can go to our webpage or GitHub repo, and there you have all the information to, for example, send a proof very easily and get started.
Got it. Yeah, it's a very sounds like a very streamlined process here. Also wondering, we talked a bit about some general use cases for the space and those even beyond Web3, but I'm also curious to hear if there are any kinds of use cases that are currently building on Aligned that you are particularly excited about, or potentially any new kinds of use cases that you want to see in the future being built with Aligned.
Yeah, we have as I told you, the Mina bridge is going to be ready sometime soon. It's finished. It's going through the audits. I don't know exactly the date, but that would be a first interesting case coming from a secret bridge. Um, in fact, RJ before Aligned was also working on bridging, and he saw that it was like super expensive to use the bridge due to proof verification. Then I think that I'd like to see more of maybe on-chain gaming. That would be something like really interesting. Like you run uh, the game off-chain, you get a score, and then you can somehow submit it, the proof and your score, and then create, for example, an online leaderboard. I think there are also like lots of applications where um, zkTLS, for example, is something really interesting that we already have like some ideas of products that we can build on top. That is to say, Aligned was like the first thing we needed to build because really you cannot use zk if every time you have to do something you have to pay $6-10 per proof. It's not viable. So now that we have these in place, we already have like several ideas. We will be sharing the updated roadmap really soon. We've been discussing with all the guys all the things we want to do. We also have like over 30 partners that we talk very frequently, and we know already how to support them and how they can send proofs to us. Um, yeah, and I think that the good part is here uh, both verification costs and proving costs are going to go down significantly, and that makes adopting this technology very straightforward. So if with this technology you get guarantees that you don't get elsewhere, and the cost of adding it is like negligible, then you will start seeing these in many other places. And we were thinking when designing this as like the broadband moment. Internet before broadband was kind of a mess. You couldn't do so many things. I remember when I was little, I wanted to download something and it was like painful. Somebody picked up your phone and then you lost everything that you were doing. And then we had broadband and people starting having like YouTube, social media, e-commerce. So I hope that this is like the broadband moment for ZK.
Mhm. Yeah, and I really love that analogy as well. And I think, like as what you mentioned, as our proof proof costs on the verification and on the proof generation part, as they lower, we'll definitely see many new applications open up. So love that analogy that you used. And just as a last question before we close, I'm wondering if there are any sort of closing thoughts, final thoughts that you have, or any sorts of announcements that you'd like to make to the audience or any kinds of like how developers who are looking to verify their proofs more efficiently, how they can get involved with the line.
Yeah, no, they can just follow us on X, or we have our Telegram groups, Discord. We are really open. You can write to us. We like talking to different projects, ideas. We want to support builders in several places. We organize also like hacker houses and everything. We have lots of friends in different countries that we like visiting. So yeah, it's really easy. I think we will be sharing more news really soon on the roadmap and everything that we want to do. But yeah, no, super excited, and also I am amazed by the level of the developers in several countries and the adoption that CK has been having there. And we hope to really work side by side with them and continue developing this great supercomputer that we want to have, which is Ethereum. So super bullish on everything.
Yeah, absolutely. And thank you so much, Diego, for joining us today. Really enjoyed hearing um, all of the advantages that come with the verification layer, the architectural design considerations that you and your team made, and then also some of the use cases that can be extended from it. So, really enjoyed the conversation overall. And thank you again for all the insights.
No, thanks a lot for having me. A huge pleasure talking to you.
Thank you.